Hello everyone and welcome. My name is Eric Coleman with IIST and I'll be the moderator for today's webinar. Testers Can Prevent Defects Too, Maturing the Test Profession Towards True Quality Assurance by Dr. Magdi Hanna. We're excited you're able to join us today. Set aside an hour to attend this webinar. This webinar is sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. This webinar is one of a series of free webinars offered by IIST. Be sure to join us for the series Agile Leadership for Agile Transformation or Fail by Tom Cagley on February 2nd from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to testinginstitute.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at testinginstitute.com. At the end of today's webinar, you'll be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Dr. Magdi Hanna. Dr. Hanna?
Thank you, Eric. Thank you. Good morning, everyone, or good afternoon, or good evening, depending on where you are joining us from. It is my pleasure to be with you today for the next hour or so to share with you how I believe that test professionals can really be a very important component of the whole process of defect prevention. And not only that, they do a great job in finding more defects and finding them effectively, but also how to help the whole team, whether it is agile or not agile team. It does not matter. What I am going to talk about today and what I am going to present to you works equally for agile and non-agile projects. And in the process, you will learn. If you decide to apply it to your project, it will work. I promise you that. And if you see or you sense otherwise while during the webinar, please go ahead and ask your question, and I will always make sure to answer it. All right, to start with, I don't know if we can argue why we need to prevent defects. Defects are there for all reasons, and we're gonna see what causes defects to be there in the software, but also the types of defects that we as test professionals cannot find during a typical test process. And a lot of defects are not being found by testers, and they end up by going to the customer. All right, so here is my simple picture that I use to motivate managers and explain to them why they need to focus more and more on preventing defects. It doesn't mean that we're not going to do testing anymore. Absolutely not. In fact, the way I'm going to explain to you how to prevent defects, you are going to do it through the test process. So I'm really speaking about how to turn the test process into a process that's not only finding defects and making sure the software works as expected. How do you turn that process into another process that does all that? And I'm emphasizing here that does that finds more and more defects, that makes sure the software or the system works as expected, and it achieves all the typical objective of a test process. And in addition to that, how it can be a very powerful process in preventing defects. So in order to understand the value of preventing defects, typically the development team works, and again, that's true about any project, agile or not. Developers work, whether they are adding in new features, they're fixing bugs, they're adding functionality, my apology here, they're adding a new functionality, whatever they're doing. And they put a build or an iteration, if you are, or any piece of software for the test team to test. Of course, the test team starts testing, and as they test, they find problems, and they will continue to find problems. And those problems, as you know very well, go back to the development team to fix. The development team continues to fix the problem, and they give you the fix, right? So that you can retest it. But you know very well what else you get with all these bug fixes. Whether you like it or not, whether the development team is willing to admit it or not, what you get here in addition to the fixes is more problems, more bugs. We call, or I refer to this as regression errors or regression defects, things that happened as a result of developers fixing problems. Now, of course, when I show this picture to developers, many developers would agree to that. Some developers will come so arrogant and reject the idea. They do not want to admit that in the process of fixing bugs, they create other bugs. Now, the literature is full of numbers about how many problems, how many defects get introduced as a result of fixing one defect. Some numbers suggest that the ratio is 1 to 4. Some numbers suggest that it is 1 to 2, 1 to 3. So the truth is, when developers fix one problem, they will introduce other problems. Now, that's not to generalize, because not every developer, when they fix any problem, they will always add more problems. That would be unfair to say, because we have some very careful developers who look at the impact of the changes they make. They make sure that if they change a piece of design, they make sure that they look around to see what other areas get affected. But the numbers that are being suggested are in the average, meaning that among all developers, among all types of software, among all types of defects, in the average, fixing one defect produces 1 or 2 or 3 other defects. So it is very, very possible that, as one developer can be very careful 1 time, 2 times, 3 times, and they may be able to fix defects without introducing anything. And then 1 time they fix one problem, in which they need to make a change to part of the database, and that screws up the whole thing. And now you find that a number of reports, a number of screens are not working the way that it's supposed to work. So, and that number could be 10 or even 15. So that's where the average comes from. Now, what I can tell you for sure that most developers I speak to and I teach are willing to accept at least, or to admit at least 1-to-1, which means for every developer, for every bug report they fix, in the average, they will introduce 1 more bug report. Okay? And they were willing to admit that. But that by itself is very bad. Because imagine if the test team works and reports, say, 20 bug reports in 1 week, for example. I'm just choosing some arbitrary period here. So a number of testers work for about a week. They report, say, 20 bug reports. They get fixed, and we and another 20 problems get introduced. Now, by the way, if you as a test professional or as a developer or as a project manager or whatever you do, object to those numbers, please share that with us. If you're willing to say, no, my developers are very careful, they never introduce any problems, or I am as a developer, I'm very careful, I never introduced. Remember, again, one more time, we're talking about average, over time, over a period of time, over a number of projects, over a number of developers. Okay? So, so what happens to those 20 additional bug reports? Of course, if we do good regression testing, we might catch up those. The problem with those additional problems they get introduced during fixing a problem is that they're not known to anybody. They're not known to the developers, or they're not known to the testers. Would be nice if developers say, here is a new build with all the bug fixes, but here are 10 or 15 or 20 other bugs in the software. You need to make sure you test those, or at least there is 20 potential places where the software may not work the way it was working before, and you need to test those. No, developers don't know that. So as I said, you might be lucky and get some of those during the regression testing, and sometimes not. And if you don't, what happens normally, those bug reports go down to the customer, go out to the customer. So, and nothing irritates the customers more than having an update of the software that things worked last week and now there are no longer works. They're no longer work. So that's the worst part. And of course, when things do not work, what happens? The customer reports the problem, and it comes back again. It comes to the development team. It just comes from a different channel. It does not come from testing. This time it comes from the customer. And the whole cycle gets repeated again. And the more bugs we create, the more bug reports. So over the years, I found out that the most effective way to prevent problems is to reduce the flow of bug reports from the test team or from customers to the development team. Because obviously, the more bug reports the development team receives, the more fixing they do, the more problems they introduce. Okay, so if we can do anything to reduce or to minimize the flow of bug reports from the test team to the development team, and from customers to the development team, then that would help great. That would be great help. Now, of course, many people say, oh, so maybe developers can do more unit testing. And you're absolutely right. Absolutely right. If developers do a very thorough unit testing, then they will catch most of these problems before they come to the test team or before they go to the customer. And that's why many agile projects, when developers do, because remember, in the non-agile, in the traditional development, developers really did not do much of unit testing. I think developers started to be more interested in doing unit testing when we started doing agile projects. And especially with the introduction of test-driven development, which is happening in many agile projects, that forces developers to do a lot of unit testing. So with that being said, the number of bug reports coming back to the test team and number of bug reports going out to the customer are reduced, but not by much. All right, so let me spend some time to explain to you what defect prevention is. Because a while ago, I put an article on LinkedIn about the topic. I put an article on LinkedIn about the topic, and some of the reactions from some people was interesting, and some people were confusing defect prevention with finding defects early in the life cycle. That's why I emphasize here. And remember, this is my opinion with all due respect to those who say otherwise. Early detection of defects is not defect prevention. Again, one more time. Early detection. So if you find, as I say it clearly here, if you find a defect anytime during code review, during design review, during unit testing, if you find that defect, then it has not been prevented. No one prevented it. Why? Because the defect is there. The defect is there. That's why, by my own thought, code reviews, design reviews, walkthroughs, all that good stuff, unit testing are not defect prevention techniques. Why? Because they still find problems, and the problems still get fixed, and they have the same effect of finding problems anywhere. The only thing about finding defects early is that, as everyone says, it costs much less to fix. When defects are found early during the design phase or the requirement phase or the code review phase, when defects are found there, they cost much less to fix than if they were found to be found by the test team or by the customer. Everyone knows that, but that's the only advantage, I would say, about finding defects early. Okay, I recall what Phil Crosby, which is one of the pioneers of software quality, actually he is one of the pioneers of quality in general, he says if the error that is not made cannot be missed. Okay, so if the error is not there to start with, then you're not going to find it. So let's talk about now a very important issue, because if you're talking about defect prevention versus defect detection, then you have to speak about quality assurance versus quality control. I am very curious to know from those of you who are with us today, how many of you have the term or the phrase QA or quality assurance either in your title or in the title of your department or team or group? So many of you are probably, QA analyst, quality assurance analyst, quality assurance manager, QA manager, whatever. So how many of you have quality assurance or QA in your title or the title of your group? And go ahead and raise your hand. And I will try to count, because the platform for the GoToWebinar does not give me a quick way to get the count, so I'll count manually. But go ahead, please, and raise your hand if you have QA or quality assurance in your title or in the title of your group or team or department. I'm expecting much more. I mean, unless I have people who are not in testing or QA with me, and I suspect I can. I mean, we can look. In fact, we can always go to your registration and see what title you put there. That's an easy way to do it. Okay. Again, I'm another few seconds here. If you have the title, the phrase QA or quality assurance in your title or your department title, go ahead and raise your hand and let me count here. I'm reaching about roughly 40%. Now it's about 50. I have roughly 100 people here attending today because the platform limits attendees to only 100. We have over 227 people signed up, but only 100 people with me today. And remember this next time. If you sign up, then please make sure you join the webinar early because, and if you decide not to attend, please make sure to cancel because so many people register and only few people. So we have 100 people joining, although we have over 220 people signed up. All right. I have probably easily about 70 people out of the 100. So 70% of us who are attending the webinar today have QA or quality assurance in their title. And the rest, of course, have other titles. Some of them may have, test analyst or test manager, or maybe something else, project manager or development manager. But as I said, we can easily go and count. So based on that, most of us believe that we are actually quality assurance people, or we are QA people. I'm sure some of you already know that. There has been misconception and misunderstanding of the real meaning of QA and the quality assurance. And if you are new to testing or QA, you'd be surprised. So I'm going to put in front of you the real difference between quality assurance and quality control, which is testing. Now, I did not make that up. This is based on the teachings of our fathers in quality assurance, including, again, Phil Crosby, including Dr. Edward Deming, and many others. If you are going to refer to yourself as QA person or QA professional, quality assurance person, okay, then your effort would have to be throughout the development. So mostly or mainly, you're focusing on a process. If you are focusing on a product, and it doesn't matter what the product is, and the product here means something that has been completed. If you are focusing on a product, trying to find problems within that product, then you are not doing a QA. You are doing what's called quality control, which is a fancy term for testing. Okay? If you are waiting at the end of a life cycle phase, meaning what? So you know what that means? You know what? Even if you participate in a design review meeting, remember the design review happens only at the end of the design phase. And the product you are looking at is a piece of design in any form. Actually, if you are looking at a requirement, at a piece of requirement, you're still looking at a product at the end of the life cycle phase, which is the phase of producing the requirements. If you're looking at code for a code review, if developers are looking at unit testing, which means they already wrote the code and they have the code that's running, that is a product. So the word the product here does not mean that it's a product that we're going to deliver to the customer. No, it's a product that has been produced through a life cycle phase. Once you are doing that, you're finding defects. Why? Because the product has already been produced. And you have no way, you cannot claim, you cannot convince me that you're trying to prevent defect in a product that has already been produced. No, when the product has been already produced, all that you can do is to find defects. I think I can easily convince you with that. So if what you're looking at is a product, you are finding defects, and that's considered quality control activity. And it's very interesting when I travel outside the United States, especially to Europe and the other countries. You don't see the term QA or quality assurance used to refer to testers or test organizations or testing groups. They always use the term quality control. Now, quality assurance, on the other hand, meaning that you are focusing on processes, any process, even it is a process you personally follow to do your job. Keep that in mind. Because a lot of people, a lot of testing professionals says, I am not hired, they did not hire me to look at processes to improve it. I agree with you. I agree with you. You were hired as a testing person, and they just gave you that title QA or quality assurance analyst or QA manager. So to management, you are a defect finder. Now, again, please understand, when I say defect finder, that includes, because some people say, no, I don't only find defects, I also make sure that the system works as expected. Well, yeah, that's also defect finding. When you make sure that, when you run tests by which you make sure that system works as expected, you are really trying to find problems, but the problems you are trying to find related to the functionality and how it works. And does it work according to to the way it's supposed to work or not? And then when you find a place in the software where it does not work the way it's supposed to work, then you actually found a defect. Absolutely. And you write a bug report. So in QA, you are focusing on a process and even looking at your own process that you follow to do whatever. Even your own process to do what? To design the tests. Your own process to execute the tests. Your own process to review the requirements and ask a question. Your own process to report problems to the development team. So we, as testers, we have our own processes, and we know that, and you know that. So QA includes improvement of all processes, including the different test processes. The test execution process, the bug writing process, the test design process, the test planning process. These are all processes. I'm sure you already know that. And if you've been in testing and the QA for a while, you know that. The purpose is to improve those processes to prevent the problems. Okay, that's why anytime you look at any process, if I look at the way I am now teaching you this course, and I try to do things to improve the way I teach the course, whatever those things are. Okay? If I try to use more graphics on my slides, if I try to to do more polls where I ask you questions and you answer, if I try to do things to involve you more, then all these things are things to improve the way I'm following my process, and with that effect, I am doing a QA. Okay? That's very different from taking my course material and going through it to make sure that I don't have typos and I don't have spelling mistakes or whatever. That would be quality control. Okay? That's very different from taking the recording of this course and listening to it after I have already performed it and find problems in the recording unless I use those defects I find. I want you to pay attention to this. Unless I use those defects I find to improve future webinars. Then if I do that, then it's quality assurance. So let's see how this applies to testing. Everyone is convinced? I'm trying to lecture you more than asking you, because when last time I did a similar webinar, when I asked people, I got people interacting with me. We kind of lost a lot of time. But please make sure to communicate with me any opinion, any questions, any question that you might have. Okay, so I don't see any questions. So please share with me your opinion, your questions, your agreement, your disagreement, whatever. All right. So the bottom line, in my own opinion, that's what I've been teaching people for many years. Tester professionals have to become QA professional in heart. Meaning what? Meaning even if you are hired to do testing stuff, whatever it is. You do test management, you are a test lead, you are a test analyst, and they call you QA analyst or not, it doesn't matter, or they give you the title QA manager or not. Every tester, in order to become very effective in our job, as test professionals, we have to become true QA professionals. Either whether QA is in our title or not. Why? Because as Dr. Edward Demings said, and I was very privileged to attend the last presentation that Dr. Demings did at IBM in Rochester back in 1982. I lived in Minneapolis around that time, and he came to IBM Rochester, Minnesota to make a presentation. I was very privileged to attend that presentation, and that was the last presentation he made. And again, as always, he focused so much on QA and how we prevent defects and how we do not go into the cycle of finding defects and fixing defects. This is the most effective way we can improve the quality of our software, guys. It's not by simply testing and finding defects, but rather by doing the kind of things I'm going to tell you today. So let me share with you the types of defects. I found that they escape the test process. So the test team does a good job, and they do as best as they can. Yet, software goes out to the customer with defects. What are those defects? Mostly code that developers have written to implement functionality that testers are not aware of. Someone says, how could that be? We are working or testing based on the same requirement that developers use to write code. Well, you got to believe me. I can tell you one story after another where the code as written by developers have much more stuff than what testers can test. And testers are not aware. What I'm referring to you here is the concept of code coverage. Not requirement coverage, code coverage. Code coverage refers to how much of the code are we testing. And my own experience with a number of projects, the worst one of them was code coverage was 58%, which means the test team with a very careful process were able to test only 58% of what's in the code. So whether you know it or not, there is a gap between what's in the code and what we test. Sorry. So we have to work very hard on minimizing and possibly eliminating that gap. That's why Agile projects do a great job. When we speak with developers all the time, and we collaborate with them, and we make sure that we are testing everything they're writing, we do a much better job than in non-Agile projects. But I don't want to mislead you and tell you that Agile projects maximize code coverage. No, no, and no. Because it's not the kind of collaboration that I hope for. It's not the kind of effort that I'd like to see happening to reduce the gap or eliminate the gap. I'll give you a way now to reduce that gap and possibly eliminate it completely, and that method works in Agile and non-Agile projects. And now, of course, you can go back, and if this is what you do in Agile projects, and I really appreciate it if you can share with me some of the things you do based on what I tell you here. Some of the things you do in your project, because as much as you are learning from me, I also can learn from you and from your projects and what you're doing. Who knows? Your team might be doing something that I have never been aware of that achieves the same goal that I'm trying to achieve here. So there is a gap, whether we like it or not. There is a gap. And we're going to work on that gap. Now, scenarios, and I know I use the word scenarios here. For now, you can replace it by, because I'm going to be talking about scenarios in a little bit as a way of eliminating that gap. Things that happen in production that no one had thought about. The user did something in production, or something happened in production that the development team did not think about it, so as a result, they did not write the code to handle it, and the test team did not think about it. As a result, they did not write any test cases to test it, and it came as a surprise. And I want you can practice on that. You can actually verify what I'm saying by getting your hand on some of the bug reports reported by customers from production. And look at the problem. Look at the problem as reported by the customer. And ask yourself, say, how come we did not catch this during testing? What I'm talking about here is defect analysis. And every organization should be doing that. Analyzing defects, not only for root cause of the defect, but also to find out why we missed it. Wouldn't you think it's a very useful exercise to know for yourself and for your team why we missed this? Did we test it and it worked, but somehow when we went to production, magic happened and it didn't work in production? Maybe. I doubt it. Although, of course, as you probably know, some of the problems reported by the customers have to do with the environment that you had no way of thinking about. But guess what? It's a part of the testing process that you think about. But again, I'm just telling you here, things happen in production we never thought about. And if you analyze defects, you'll find more than 90% of defects reported by customers are defects that, or in general, reported from the field, from production, are defects or are scenarios that you did not think about, The development team did not think about. That's why code was not written to handle it. Test cases that were not written to handle it. That's why when developers fix those problems, you have to write additional test cases to test them. Because otherwise, if you actually thought about them and if you actually tested them, you should be able to go back to your test suite and pull out those test cases that you have written to test those. But the truth is, no, you don't. You always write tests to test the bug fix. Please, again, if I'm saying something that does not make sense to you, just react to that with by clicking on the questions tab. All right. And the third type, as we just discussed, is bad fixes. And I put the picture here again in front of you. Bad fixes mean that, defects that happened as a result of developers fixing other problems. So these are, in my opinion, the three types of defects that escape the test process. If you get your hand on bug reports from the field, analyze them, and ask and say, what type of defect is this, and why didn't we catch it during testing? You're going to find it must be one of those three. Otherwise, why did it escape the test process? Any agreement or disagreement? Let me know. I'm looking here. Okay, not really a question, but Jill is sharing an example. Okay. All right. Let's talk about closing the gap. Now, if you still by now not convinced there is a gap between what developers do and what we can test, now I can elaborate more, but I hate to waste our time, beating a dead horse, because again, if you've been around for a while, you know that it doesn't matter what we do. There will always be code that's written that we as tester professionals do not test. Now, no one should tell me that, oh yeah, because this code should not be tested. No, not at all. It's a code that gets executed in the field and it does something. That's why the concept of code coverage is very critical. And that's why I have been putting a lot of effort for many years now since I worked on that project in the mid-90s. And as I told you, it was a very large project, and the code coverage was 58%, and was a disaster. It was a large government project that had to be canceled. And the gap was there not because testers did a bad job or developers did a bad job. The gap was there because the infrastructure and management allowed for that gap to exist, in my opinion. We can leave this discussion to another time. So yes, ultimately, ideally, we should be putting out systems that have close to 100% code coverage if we are eliminating the gap. But I'm going to tell you that this is never going to be the case. So if you can raise your code coverage to about 90%, and there are tools out there, commercial tools, that will measure code coverage. I'm not suggesting that you use those tools or anything. I'm just telling you that the concept of code coverage, what it means, and there are tools there that measure that. So the effort we're going to be doing now is to, okay, here is a discussion. Why there is a gap? I mean, if you're working based on requirements or user story, if you're working based on requirements, so you know for sure requirements are never complete. Requirements are always ambiguous. The way developers interpret requirements is very different from how developers how testers interpret requirements. Oh, of course, you can do a lot of things about requirement reviews and so on, but we don't do a very good job there. Now, someone says, oh, we're not using it. That's why we're not using requirements. We're using user stories in the Agile project. Well, guess what? With respect to incompleteness, I'm going to tell you that user stories are much worse than requirements, right? They are. User stories are incomplete. Now, of course, many Agile teams do a good job in taking the user story, analyzing it, writing good acceptance criteria and so on. And those acceptance criteria help clarify a lot of things about the user story. But again, I have another presentation which I made about, roughly 3-4 weeks ago. It was about acceptance criteria versus scenarios, and I explained that. And this webinar is recorded, so you can look at it on the IIST website. Or actually, it is on the Romana software website, because I did that webinar for Romana software. All right. When I say most of the details that come up during development, this is 100% true, whether the project is Agile or not. And it is more true for Agile projects than non-Agile. So developers start working and things, and they say, okay, let's get started. And if we have more questions, we can, and we keep the questions open even during development, and now developers start getting more details. And I'm not opposing to that. I'm not opposing to more details to come during development, as long as developers and testers are equally aware of those additional details. If developers are going to acquire more details during the development process, and testers are not going to be aware of those details, guess what? The end result is always a gap. Okay. Whether you like it or not, developers are going to make assumptions about things, and they will write the code based on their assumptions. Guys, I'm sharing with you my experience working with developers for so many years. They will always make assumptions. And majority of developers will not share the assumptions they made with testers. And they write code and they do design based on those assumptions. And whatever they write, if you're not aware of those assumptions, you are not going to write test cases to test the code they write. And that's another source of the gap. We all know that requirements and user stories get adjusted and changed during development. One more time, I am not opposing to that, because that's the heart of the Agile framework, that things will change. Things will change, fine, as long as testers are aware of every change. So it looks like one good way to minimize the gap is to adopt a very collaborative development and testing process. And that's what I'm about to tell you. And that's the process I'm about to share with you. And the end result, because of the gap, test teams are not able to test more than 50 to 60%. Oh, okay. Now, someone says, oh, that can't be that bad. I'm sure we test at least 70%, 80%, but that's about it, okay? That's my experience. Whether you can agree or not, if you disagree, please react on the questions tab. Okay, here are a few things I'm going to suggest for you to close the gap. Collaborative requirement and user story reviews. Absolutely. Now, someone said, I thought you just said requirement reviews are not really a way of preventing problems. Well, Remember, we're preventing problems in a different way. We're simply saying we're going to do collaborative requirement reviews and user story reviews. And I'll show you a little bit what I mean by collaborative. Why? Because we want to come to the same understanding of user story and requirements. We want to bring all what I'm doing here, all these 5 bullets are about, actually the first 5 bullets are about bringing development and testing to the same page. I want to make sure that developers and testers have the same knowledge and awareness of things. I want to bring the user story down to a level that if developers take that user story and write the code for it, and testers take the same user story and write the test cases, those test cases will be testing all the code that developers are writing. And by that, I am eliminating the gap. Now, is it going to be that case? Not exactly. But at least testers will be testing much more of the code written by developers. Some of you have learned from me the concept of scenario-based development and testing, and I will bring it to you just to remind you, or for those of you who have not seen it before. In my own experience, and based on what I've done over the last, since late 90s until now, scenario-based development and testing, as I explained it to you in a little bit, is probably the most effective way for defect prevention, because you are preventing defects right from the root. You are eliminating the gap. You are making sure that you're finding as many scenarios as possible before developers even write the code. Right. Scenarios must be collaboratively reviewed and validated. Absolutely. Now, if someone says, well, we're using Agile, we're using user stories, we're using acceptance criteria, okay, fine. Then collaborative acceptance criteria validation. That's what you have to do. So everyone has to agree on those acceptance criteria. Everyone has to agree on those scenarios and how they're supposed to work beforehand, before developers even start. Now, certainly attending code and design review meetings are a good, amazing way, very effective way to close the gap, because during code and design reviews, the testing team is supposed to learn about a lot of things, assumptions, changes. So I'm going to go back to the previous slide here. All these things that happen in the first 4 slides, you can learn about them in a code and design review meetings. But that's provided that you do effective meetings, not to go to a meeting just to sit down and listen. There are ways to do code and design review meetings. Now, in Agile projects, those meetings are not happening because we don't have time for them. So what I suggest here is we create some sort of a daily update meeting, or if the project is not Agile, you can do a weekly update meeting. The purpose of the update meeting is not the same as the stand-up meeting that we do or the Scrum meeting we do in an Agile project. No, the purpose of this meeting is to update, is for the development team and the tested team to update each other about what things happen that can affect the other person's job. Again, trying to eliminate the gap. Okay? I suggest it very much as a daily meeting. At the end of the day, as a developer, I could very well share with my testers what I did during that day that affects the way they do testing, whatever that means. I've done this in the past. It worked great. All right. In order to, and this last bullet here is about what? Is about catching. I'm going to go back to the previous slide here, just to remind you of this. I'm trying to catch a lot of those errors. And the way to catch them is through regression testing that's based on impact analysis. Okay, I'll talk about it a little bit. I know I have a total of 5 minutes, so let me see if I can finish everything in 5 minutes. So I've been teaching people how to do regression testing based on impact analysis for years. And that's a very powerful way to do it. Here is a scenario-based development and testing. Very simple diagram to describe it in a few minutes. Whether you have requirements or user stories, forget about those for now. Use cases are much more complete, much more involving than user stories and requirements. Excuse me. As I said, you must have collaborative analysis and review of requirements or user stories or use cases, whatever. And the questions must be asked and answered and all this documented. And the collaborative meaning that we do it all at the same time, although we may not be sitting in the same room. Let me just go to the next slide very quick. I think it describes how the collaborative process works. It's a synchronous collaborative process or review. You got to share the repository here. You're using simply what you're doing here. You're using a collaboration tool. And the project team are anywhere in the world. It doesn't matter where they are. They live in their own time zones. And they take one thing at a time, whether it is a requirement or a user story or whatever. And they all collaborate on reviewing it, even in a different time zone, asynchronously, meaning that not at the same time. I put my user story at night or during the day. My developers somewhere else might be sleeping by that time. When they wake up in the morning, they will see my user story. They will ask questions. They will put their questions in the tool. And by the time I wake up, I find their questions. I answer their question. They can see my answers next day, whatever. Okay, this is a big process. I can explain it in another webinar, but that's what I meant by collaborative. Then, based on these questions and answers, we come up with scenarios. And the scenarios have to be developed collaboratively as well. This process, by the way, is explained in more details, and I'm not saying this to convince you to take the course. One of the courses I teach for the International Institute for Software Testing is Best Practices in Software Test Planning and Design. And you actually, in that course, you practice on doing this process. Okay, so you build the scenarios in a collaborative manner, and then you go through the validation of scenarios to make sure that everyone agrees on them. Okay, and everyone is on the same page with respect to those scenarios. And everyone agrees on the expected outcomes of scenarios. Now, once you do that, only then, only at that point, developers can go and write their code and design. Testers can go and write their tested design, which includes their test cases and test scripts and so on. With that being said, I can tell you, by the time we come to execute our tests against the code coverage have increased, requirement coverage have also increased. We found a lot of scenarios that normally we did not find. We minimized the chance that customers will do things that we did not think about. All right? Impact analysis very quick. Let me finish this in about 2 minutes and I'm done. Absolutely. Developers must always be responsible for identifying and analyzing the impact of their change. If a developer is going to take a piece of code or a piece of design to change it, they must know the impact of the change. A developer who does not do that does not deserve to be a developer, in my opinion. You cannot take anything and change it and not be aware of the impact of the changes you made. That is a no. That's a terrible thing. Okay, so you have to, developers have to identify it and analyze it. And then they must be reported and discussed with the test team. That's very critical. Either through impact analysis reports. If we want to be informal, we can do this during the code and design review meetings. Developers will share with others what changes they made and what they believe to be the impact of those changes on the rest of the functionality, so that the test team can go now and build the regression test suite based on this analysis. And as I said, if code and design review meetings are not happening, you can do daily or weekly update meetings, in which, again, the update meetings are about sharing anything that can affect each other. My conclusion is that as a test professional, who might be referred to as a QA professional, regardless, you always strive for preventing defects. Find ways to reduce the number of defects you write. You would be better off, far better off, if you write less and less bug reports every day. Management needs to understand that rework and fixing problems will always, of course, more than, other than costing more, it will also produce more defects. Okay? Because yes, of course, fixing problems, it does cost much more than finding it the first time, but or preventing it the first time. But it will also introduce more problems. And remember that last bullet. If you find defect anytime during the life cycle, you did not prevent it. Sorry for taking 2 minutes beyond my time. Thank you for being with me today, and I hope you can go and listen to the rest of the recorded webinars at the IST website. I now will turn the webinar back to Eric.
Thank you, Dr. Hanna, for your time today. And I want to thank everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. Again, this webinar is one of a series of free webinars offered by IIST. Please join us for the next webinar in this series, Agile Leadership for Agile Transformation or Fail, by Tom Cadley on February 2nd from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in this series, go to testinginstitute.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day. Thank you, Dr. Hanna.
Thank you, Eric.